Very good. Right. Well, thank you for having me this morning. So what I'm going to talk on is something called the Virtual Energy System Program that Alex talked a bit about in her presentation just before the break, but I'll give a bit of context. As an introduction, my name is Simon Evans, and I've got a couple of hats. The first is I work for Arup, the engineering consultancy, where I'm the global digital energy leader, which means I look after digital across our energy sectors. But the second, I'm working really closely with an organization called ESO, the Electricity System Operator, in the work they're doing around the virtual energy system. So on that, the challenge to set the scene is the virtual energy system, and indeed the National Grid ESO, the electricity system operator, are the system operator who are responsible for, in essence, keeping the lights on in the UK, for running and balancing the grid. Now, they have a number of future expectations that are being put on them by demands from consumers and otherwise, such as running a net zero carbon system by 2035, connecting huge amounts of offshore wind also by 2035, and the need for flexibility across the entire system to allow us to meet the demands that we're expecting to see grow. Now, all of these future expectations are putting significant challenge on a system already under pressure and already under stress. So that in mind, well, how do we deal with that? So with that as the context, we're doing some thinking and realized that actually the challenge here is that we know the energy system is absolutely changing. And in order for us to achieve our aspirations as a society of a net zero energy system, we really require an integrated energy system. And in order to operate an integrated energy system, which will be necessary to achieve this, we are needing to require us to model a range of scenarios that exist across the sector. And modeling those range of scenarios will require visibility of the system behavior. And that visibility of system behavior of a dispersed system where we don't necessarily own any of the assets, we just kind of manage and operate them, requires data sharing. And that data sharing requires a common framework that's both social and technical in nature to facilitate interoperability. Now, when I say social and technical, Alex touched on it earlier, the social side, of course, is things like policy, regulatory, legal, skills, which arguably are the most important things, because the technical side, or the technology that goes with it, is really a known problem, and many solutions exist today to let it to happen. It's the socio side that's the part we really need to put the emphasis on. Now, looking at this diagram, we could complete the circle further and say that actually, in reality, in order for us to achieve net zero, we fundamentally require a common social technical framework to facilitate interoperability. And without that, then we can never get there and we never complete that journey. So with that in mind, the Virtual Energy System Programme was established by National Grid ESO, and its ambition was to enable an ecosystem of connected digital twins that can facilitate the transition to net zero and allow things like energy optimization, carbon reporting, investment planning, and just generally the net zero energy transition. Now, Alex said earlier in her presentation that achieving connected digital twins is a long vision and that it's not something we can do overnight. And indeed, based on that, we realized that this is actually our North Star. And getting to this connected ecosystem is probably a 5, 10, 15, even 20-year journey before it's fully realized. But the first step on that journey is quite key. And that first adjacent step in our mind is reducing the friction of data sharing at scale across the sector, which in energy is the term we're using at the moment, is something called the data sharing infrastructure. So our first adjacent step as the program is to help create this common data sharing infrastructure, which after doing so will reduce the barriers and friction of data sharing that will then in turn allow us to continue on the journey of creating this ecosystem of connected digital twins to enable that transition to net zero. Now, when I say connected digital twins, obviously it means many things to many people. I appreciate this is a digital twin conference, but just to kind of bring us back to kind of the concept to allow us to talk through the rest of the presentation, if we take a simple diagram of what a digital twin is, we would use this one, which is created originally by CDBB and the National Digital Twin Programme, but I like it because it's simple and it shows that connectivity from a physical to a digital asset via data, that data importantly being right time, not real time, a small semantic difference, but really important. Nothing really ever needs to be real time. It's about the right time based on the use case you're trying to answer, where you, of course, in the digital world derive insights, make decisions, and importantly have that feedback loop back into the physical where your outcomes are delivered. Now, this diagram shows a simple wind turbine from an energy context, but what we know is that an energy and a wind turbine is actually part of a bigger system, a wind farm. And in reality, the wind farm is part of an even bigger energy value chain of transmission, distribution, and ultimately the consumer. Now, in the physical world, these assets are connected via physical infrastructure, the energy infrastructure that many organizations, including my own, help manage and maintain. Now, we also know each of these actors is typically a different legal entity or owner-operator, which means straight away you've introduced complexity about how can you connect these things together. And because they are their own legal entities or owner-operators, it's also logical to assume that each one will have its own digital twin, or digital twins, indeed, answering multiple use cases to add value to that business operation. Now, in this diagram, if you take a look, something's missing. The equation isn't necessarily balanced. What we're missing is that digital connectivity along the bottom, that kind of mirroring the physical connectivity. Now, that digital connectivity, that interoperability, or in the first adjacent step, that data sharing infrastructure is the key focus of what we're trying to achieve with the virtual energy system in collaboration with programs such as the National Digital Twin Programme. Now, looking again at this future vision, the North Star of this virtual energy system, and the idea of it being socio-technical, we kind of had to think and understood what that would look like. And we broke it down into 4 categories: people, process, data, and technology. Now, each of these categories has a number of factors or attributes that we think need to be addressed in order to achieve this ultimate vision of a connected ecosystem of twins in energy. Now, starting with these, I'm going to look at data first, which is probably the hardest, but also the easiest to look at. We've got a number of things that we know need to be done, such as aligning models and taxonomies that exist across the sector. And this is about aligning with work that already exists rather than creating anything new for the sake of it, because that's not helpful. Or there's establishing the right data management, data governance, increasing visibility and sharing of data, and of course, fundamentally managing the security of data, because all of this has to be security minded, which I'll talk about in a couple of slides' time. Then moving on to the process aspects, there's things like, again, aligning around codes and standards that exist in the sector. Energy is quite a large and complex sector with many types of energy vectors and generation types, and there's codes and standards that exist for all of it. So how can you bring those together to understand what the right standards are for the right data sets so that the right things can be done with them? And of course, engaging stakeholders, making sure you're doing this with the sector, not to the sector, creating the right governance model for the long-term success of what we're trying to do here, which is system-wide digitalization, really. And determining the operating environment, realizing that no one does this for free. There has to be a way of it actually being commercialized in some capacity. And this is very much following the mantra of collaborating on the rules, competing on the game, where if we can set some core fundamentals, the rules, if you will, then each organization in the sector can compete on the resulting game based on their own commercial interests and drivers. And then the people aspects, really important things like defining the right roles and responsibilities, raising awareness and fostering the culture needed for data sharing, connect digital twins within organizations across the sector, and importantly, building the capabilities and skills for the next generation of people that will be using it. And finally, technology. Now, I'm not going to loiter here because, again, I think the technology aspect is something that's already solved. It's just about doing it and addressing the people, process, and data aspects first. Now, looking across all of these different attributes, a number of them, particularly the ones I've highlighted here, are of key importance, we think. The first amongst equals, the ones we need to put the initial attention to in order to accelerate the rest. And each of these, the programme has been very active in putting out some publications, which I'll share in the chat window after my talk, on exactly our views on how you might engage stakeholders, what it means to raise awareness and foster culture and create that organisational and sectoral vision for connected digital twins, how you might increase that visibility and sharing of data, what the models and taxonomies could look like, and of course the tech stack associated, which again I'll talk about in a couple of slides. But a big driver across all of this, and one of our observations kind of collaborating with industries around the world, is that the governance framework to support it is less talked about, but probably one of the most important aspects that needs to be done in parallel rather than sequentially to many of these things. So with all this in mind, we had to think about how we can do some stuff here and now, because it's some great slides, some great vision, but of course we need to show results fast because in part, this is a hearts and minds campaign to the entire sector. So as Alex referenced in her first presentation, we've been working really closely over the last couple of months with the National Digital Twin Programme, collaborating together to understand how from energy and the work we're doing, we can connect into the broader vision that they're trying to do across all economic infrastructure. And if we can collaborate together and create that connectivity, then in theory, together, we will then be able to work and also transcend sectoral and organizational boundaries even greater than our own. So how can energy and water work together, for example? Now, we've been going through a bit of activity over the last couple of months to map this out in detail. And as you saw from the great examples that Alex was sharing, they've done some really, really impressive use cases and deliveries. How can we also bring our kind of view and our sectoral angle into that and see what that means? And we've been doing this supported by a number of delivery partners, Arup, the Energy Systems Catapult, and Icebreaker One. And being observing in this process has been the government department responsible and also the regulator, which are the two names right at the bottom. Now, bringing all this together, we came up with a high-level design, which, of course, on here is semi-technical, but shows the kind of extent of what we're looking at. And there's a number of aspects to this that align with some other industry trends and things happening, particularly within the energy sector, called the data sharing infrastructure, and the various functional components that we think need to exist in order to make this happen, which we've simply labeled here, prepare, trust, and share. But I won't go into necessary detail on that at the moment. And we took this high-level design, we worked together, and we mapped out a pretty detailed application architecture, and it goes even more detailed than this. And again, I'm not expecting you to read the text on the screen, but more showing that there's some substance behind this of how we think this could be delivered from a technical nature, but also the supporting processes and systems that need to be put into place. And we've done this through a very use case-driven approach, because you can build tech for tech's sake, but that's not helpful. It's about understanding what the value is, how you're going to answer the right questions, and how you're going to show an impact fast into the sector. And for this, we've chosen a very simple use case for our initial proof and demonstration of it around outage planning, which for those familiar with the energy sector is something that not many people care about in a huge amount of detail, but it's critical for how the system operates and keeps running. And therefore, taking this, and it's a process we can easily do a simple A/B comparison, how it might work before connected digital twins, how it might work after connected digital twins, and what that would mean in terms of return on investment. Now, of course, there I just used the word connected digital twins, but in reality, what we're actually doing is just enabling data sharing and reducing the barriers and friction of it between various actors of the sector, trending towards that vision of a connected physical digital system. But this is just one use case. And of course, we're not limited by one. We've got many. And these are three others I've got on screen here, but there are many more than that. And each of the use cases we're picking as the system operator, where our role is to manage and maintain and run the system and keep the lights on, are focused around things that at the moment are important to us, but also important to the sector. So balancing the system in general, understanding how we can get the most out of the assets that are connected to it, balance the demand between the consumers and generators, and all various aspects that ultimately benefit the consumer. Now, a big part of all of this is the idea that we need to be absolutely security-minded as we go through it, because cyber has always existed, and just because we're starting to connect assets together doesn't mean a new threat's arrived. It just means we need to be even more cognizant of what's happening. So we've been very, very conscious in taking a very security-minded and incremental approach to how we do this, which is broadly represented on this diagram here, where the x-axis is showing the kind of sequence of development, if you will, of the various parts of our project, going from where we are today through to kind of the live operational case in maybe a year or 2 years' time. Now, each of these stages, you proportionally increase your capability and your maturity of how you address cyber, but also generally physical security as well, in response to what you're doing and who the actors are involved, from going from sandboxed environments to kind of private betas, if you're using that language, through to public launch. And through all of these steps, it's really important that we consider things like the governance and risk management, cyber operations, instant detection, and response and reporting, and what that means for us. Now, of course, all this is great, but it's also really good to have a bit of a long-term vision. Now, we mapped out how we might do this, how we might deploy this in anger across the sector. And we put a bit of a timeline together between where we are today, 2023, 2024, and 2035. And the reason we put 2035, and you might think, wow, that's pretty far out, is that by 2035, we have aspirations here in the UK to have a decarbonised and net zero energy system. So it's a good state to start with. But also you could say that if we haven't really digitalised and decarbonised the system by then, the world's probably on fire in some capacity. And therefore, that's really kind of the bookend, the end date we have to work to. And if you look across this timeline as well, there's a number of sectoral dates that are of quite significance that will really help drive and get momentum into the sector. And I've got a couple of them listed here, and those familiar with the UK energy sector will recognise what some of these are. But much of it's about the regulatory process and regimes that are coming into play. And across this roadmap, we again then mapped out a couple of time horizons that we thought were practical to address. And just to kind of read these out simply, it's the first about getting a really valid minimum viable product or minimum viable thing that can be rolled out to a select number of users over the next 18 months or so. And beyond then, it's scaling it up and rolling it out to what is termed the regulated networks, the gas and electric networks here in the UK that are under regulatory powers. And why that's being launched is the government have been very proactive in many of their publications talking about how they intend to use this for regulated networks in the future. And why that's really important to us is in the energy sector, they're quite a powerful organizational group. And by regulating it and rolling out to them, you immediately create a critical mass in the sector, which means partaking is easier than not partaking. And once you have that critical mass, momentum and success kind of drives from there. And they have periodic phases of continue to roll out, scale out, and come to a business as usual state. And there's a number of activities that exist across all of these, and a number of enablers as well, that I won't read out in detail. Now, the one interesting thing when looking at this is many of you might say, that's a long time. Why can't you get this done in a couple of months? Well, of course, the tech isn't the hard thing. We could build the tech in a matter of weeks if we wanted to. What's really the challenge here is the people, the process, and data. And it's easy to dismiss that and think it's trivial or easy, but it's not. That's the real challenge that's driving much of these timelines, rather than the tech build itself. But looking at this first segment here, over the next 18 months or so, and driving into that in a bit more detail, we've got a couple of stage gate milestones we're working through. The first is to get a pilot stood up around a very known, tangible use case, which we can then scale into an MVP over the following months. And as you go through that process, onboard and bring online more use cases that will add real benefit to the sector in terms of what they do and the value they add. And these use cases, of course, being things that are of sectoral and governmental priority and also really help towards the transition to net zero. Now, in advance of that, there's a number of things that we're also doing as key enablers, things like roadmaps, specifications, business cases, and of course here governance as well. All these things have to be considered in the round because it's not about just building tech for tech's sake, as I say. It's about making sure that we're following a socio-technical approach of people, process, data, and technology. Now, the final part I'll say before my final slide is that as we go through this, the way we best represent it is by that really crude Rubik's Cube, if you will, along the bottom, where every single stage of this, you're completing the maturity and completeness of this data sharing infrastructure through use cases, the building the requirements and features required, obviously on top of the core infrastructure that exists. And if we go through this completeness, and as you've probably seen from the color coding, they go from red to amber to green, but never really fully complete. As there's a logic that this type of data sharing is a bit like galaxy redshift, where it's always going to grow and continue to expand over time. But the point is, this is the first step on the milestone. Reducing the barrier and friction of data sharing is the first adjacent step in order for us as a sector to achieve the long-term vision of a connected physical digital system or an ecosystem of connected digital twins. And the work we've been doing, as Alex said, in collaboration with the National Digital Twin Programme has been extremely powerful in us understanding how these things can connect and how we can transcend organisational and sectoral boundaries beyond just energy, as we recognise that we're not necessarily an island. We have to work with everybody to get to a net zero future. Now, the final thing I'll say is that we're doing all of this in the open and publicly because there's no benefit working in silos. Back to the quote of collaborate on the rules, compete on the game. How can we share knowledge and experience to make sure everyone's learning from each other and we're progressing at the right pace? And there's a number of ways we do this, but some on screen here are we've run a number of industry advisory groups where we ask experts from industry to come help and advise and critique the work we're doing, because we're not hiding it. We want you to comment and show what you think. And we do these around a couple of categories of people to process and data and technologies. And of course, the cases, and so add the real value going forward. Now, I'm coming into land now, and the final slide I'll say is that we would be really keen to hear from you. What we're doing here in the UK with ESO and the work around the Virtual Energy System Programme is something we actively want to share and collaborate with other industries around the world. So if you're interested, please do get in touch directly with me or via the mailbox on screen, or just type Virtual Energy System into Google or any other search engine, and we're the first result. It's been great speaking today, and very happy to answer any questions. Back to you, Mark.
Simon, that was absolutely brilliant. Thank you very much. There's so much to like in what you said there, and I think your emphasis on the socio-technical, I think, is is really important. You know, your analogy talking about it being like the galaxy redshift, I think, is exactly right as well. It will always expand. There's always going to be more. But I think one of the things which is so impressive about your work is that these are real solutions working with real systems, and you're going to be delivering real benefits. And I think, if I can say it, that the real solutions you're delivering are socio-technical solutions. And it seems like it's so important that you've identified that it is that you're doing, not just the technical. Pardon me. So we've got a few questions in the chat. What I thought I might do is actually ask the people who pose the questions to come off mute and pose them directly themselves, because we don't have millions of people online. I think we're tight enough and friendly enough to be able to do that. So Arthur, I'm asking you to unmute and see if you would pose your question.
Yes, certainly. Thanks so much, Simon. That was fascinating. And my question might be a little too detailed for the presentation that you did, but one of the things we've wrestled with in digital twins is not the gradual change, not the steady progression in the data, but sudden bursts of activity. So in this particular case, I'm asking about the sudden proliferation of EV charging stations, which in North America seems to be having a dramatic effect on the distribution channels for energy. And so I'm kind of curious about how you manage those aberrations.
It's a really, really great question. And indeed, one of the use cases that I very briefly put on the screen was looking to address some of the challenges that come exactly with that as we're starting to see more micro generation and micro consumption happen across the system. So people putting solar power onto their roofs, for example, or wind turbines in their garden, or EV chargers and EVs across the grid, which are both a consumer but also a potential battery. How can you manage that? What do you do with that? And that's one of the reasons, really, that we are doing the work we're doing, that in order for us to really fully leverage all of that, understand that landscape, digital twins will have a role, for sure, kind of that connection between the physical and digital. But again, back to that first adjacent step, that unless you have the data sharing in a standardized and consistent way, you're never going to be able to release the value because you just can't access them. So what we're looking at is that step of, actually, if we were to facilitate and reduce the barrier of friction of that data sharing, bring that together, what would that mean in terms of then being able to run any type of analysis, simulation, and modeling, whatever it might be, to answer and address some of those challenges? We're not quite there yet, of course, because the sector's large, multiple actors, multiple legal entities, but it's about, I guess, picking the use cases, and this is one of them really, where you can get quite impactful change. And the other part of that, I'd say, is that many of these programs can often be perceived as, oh, just another tech program doing some tech stuff. To kind of really double down again on that socio-technical side, a big part of what we're doing here in all these demonstrations is pretty much hearts and minds campaign. You're trying to show people there is value, and then when people get on board, you continue to build momentum rather than going away and coming back with the ideal solution that no one cares about, and by that point you've lost political will and your funding is being cancelled.
Yeah, I guess the techno-social aspect of this is that you actually want to illustrate when you're being successful, because nobody worries about hydro when it works. It's when it doesn't work that it matters, and you actually want to illustrate that the reason it's working is because we've done this great work.
Absolutely. And there's also a really interesting part here of, and we've observed this a lot in energy, because in the UK sector, there's been a period of rolling out smart meters to people's homes. And as an analogy, when you get a smart meter, you often get an in-home display that shows your usage. And you might get that and think it's fantastic for the first week, and then you stop caring, because a lot of people just don't actually care. It's like, watching YouTube or any other streaming platform. You don't care how it works, or you don't care how the bandwidth for the internet's throttled so everyone can watch Netflix on a Friday night. You just want to watch Netflix. So some of this stuff is really cool, but actually at the same time, people don't care. They just want to see the outcome. So you leave with the outcome and the change rather than the tech and the kind of the stuff behind it, because no one apart from probably this audience, because we're all here listening to it, really care much about that.
Perfect. I'll hand the speaking stick back to you, Mark.
Yeah, fantastic. Thanks, Simon. Kate, can I come to you for your comment slash
Yeah,
question?
absolutely. Thanks. And thanks very much, Simon. That's the first time I've seen that presented, and it's really sparked a lot of thoughts. So it was a great presentation. My question is about that socio-technical approach. I heard you say, and I totally agree, the industry can build the tools. That's not the challenge. It's getting the right people around the table with the same vision and the same, I suppose, risk appetite and other, I suppose, more governance related questions. In Australia, we've got a regulated but extremely competitive energy sector. And it seems to me that the commercial side, the financial, who's creating value, who's capturing the value, how do you get people to have a mature and sensible conversation about that when everyone thinks their data is, the world's most, valuable asset to sell? How are you tackling that challenge?
It's a really, really great question. How we're currently looking at it, and by no means is this the final answer, is that the reason we've gone for the regulated network groups as being one of the first key users. And I say that because at the moment they have, in the UK anyway, put in place a bit of let's say an agenda where it's about, and the way we best term it, presumed open, where in general those organizations should by default look to open up their data sets unless there's an explicit reason not to. And there's a process we put in place across the regulated entities for triaging and understanding if it is something you can open up. And of course, if there's cyber risks and you have to be sensible to that, then don't. But presumed open is the default, not presumed close. Now, there's a real benefit here that a lot of these organizations are then, because of that, opening up data sets and obviously sharing elements of it that are sensible. And then there's a difference between open data and shared data, and that's quite key. Data should be shareable, doesn't mean it should be open. But when you have all this data that's shareable, and if you go for the regulated networks where, in a way, you can stick and carrot them to do so, you create such critical mass, and that's the key thing here, that the barrier to entry is, the reason to partake is obvious. And that for us is how we're addressing it. And as a simple analogy, a number of years ago, when the web first started, metadata tags weren't necessarily so prevalent. And before search engines, became the thing, and remember your first page of Bing or Ask Jeeves or Google. And a number of the big operators got together and said, like, if we define common metadata tags, then we can all index the pages in a consistent way. And therefore, as a content producer, if you didn't use metadata, you were invisible. So therefore, you drive standardization by virtue of being seen. In the same way, can we apply that to energy? If you have a critical mass of the sector that are partaking, because you have a regulated duty to, most people in the sector want some capacity of that data. And therefore, in order to get that data, you also have to be on the system. And then you drive adoption that way. And then you have a critical mass that hopefully snowballs. And of course, there is commercial drivers in this, and we can't be ignorant to that. And how we address that, I think, is going to be a challenge we have to go through over time. But again, the first adjacent step, make data shareable, not open. And once it's shareable, we can reduce that friction and unlock some great stuff. And if people could commercialize it and you can create markets, fantastic. That's great.
Wonderful, thank you. That was a really good area to explore. I wonder if we can just squeak in one more question, and then we'll go to the break. So, Kamutha, to you.
Thanks for a great presentation. Luckily, my question is, I think, really an extension of Kate's, so not going to a completely new subject. I love the vision around net zero as well, and when you showed us how the digital twin would be created, it was all the way down to the home level. Individual homes would be included. And so I suppose my question was around whether you see a conversation needing to be had with the wider public about consenting to share their data, while the energy companies may own that data, pulling individual users or homes' data into this digital twin, might raise questions ethical questions in a broader sense, whether you've thought about that. And I also think about this in light of some of the more recent conversations that have been had around sharing NHS data, where the NHS tried to do that nationally, and there was sort of a big public sort of backlash against that. because, you know, bringing it all together is one thing, but not being able to very precisely explain how that data will be used and what it will be used for caused a lot of concern.
Absolutely, and really great questions. So to kind of respond to them in turn as such, consumer data is a big area for sure, and there's a whole raft of stuff happening in the UK and across all legislated areas around consumer data. We're approaching it in a couple of ways. Firstly, because our role is to balance the system, in some capacity, knowing what a consumer does is irrelevant for us because you aggregate it up, which isn't saying we're being ignorant to it. We're just saying that's a knotty problem and it can easily block progress. So let's look at the areas where we can get progress. And why I'm answering it that way is, in essence, this is back down to the idea of making data shareable. It doesn't mean all has to be shared, because consumer data is just data. I mean, it has obviously association and it kind of tags with it that make it more sensitive. But if you can put in place the fundamentals that allow any data to be shared, you can obviously decide what you share on top. So that's why we've approached it from the spectrum of, if we're going to get this to work, let's pick the stuff that's not going to be blocked by that sentiment. But of course, not being ignorant to the fact that we need to consider consumer data, one of the use cases we're doing at the moment is something that's called CrowdFlex. Now, what that's looking at is domestic flexibility, which means how individuals in their homes can turn up or turn down, so turn off your washing machine or turn on your washing machine to increase or decrease demand. And that requires consumers to consent to partake. And the way we're doing so is through their energy providers. So we're partnered with energy providers who are then in turn going to their customers, asking them for permission to take part in trials and seeing how that works. So we're trialing it in the safe area with people who have consented to join the system so that you can prove it works before you roll out something that kind of everyone hates. Now, the other important part of this, I'll say, is that in our model here of data sharing and what we're doing, what we are intentionally driving is a decentralized model. So there is no giant central data store. Data is always housed by the owner of the data and exchanged when it's requested, which means we're not doing a monolithic platform and bring everything together and people get concerned about it. And in doing so, we're wanting to implement the thinnest possible layer of process and technology to make it happen. This isn't about just building loads of tech and making huge monolithic, 20 IT projects. And you can see some of the scandals in the news about those type of things at the moment. This is about making something really light, thin, that can work. And actually, in essence, is proven, because as Alex Luck showed in the first presentation, the integration architecture is live. It works today. It's been rolled out across customers. You can download it open source off the internet. There you go, step one done. Now, how can we put in place the governance and the process that allows that to happen, so that if you do have things that go wrong with consumer consent, the right accountabilities and responsibilities in the right place? So hopefully that gives a bit of a picture. We're not being ignorant to it, but we are also realizing you need to start by starting. So we'll pilot some stuff in a safe space, but focus on the areas and ultimately just try and get data shareable, not necessarily shared.
Kamutha, thank you very much for your question, because that's opened up a brilliant answer that I think really emphasizes something super important for what we're working on here. Simon, you're talking about it being shareable is the important thing. And I think also your comments around how thin the technical solution is in a kind of a decentralized type of architecture is a really important thing, basically for the whole day. So Simon, thank you very much indeed. That was a brilliant session. And as the comments are coming in, people saying really useful insights. Thank you, Simon. It's true. They were great insights.